Hi everyone, welcome to Computer Vision Fine Tuning. We introduce a common technique in transfer learning fine tuning. As shown in the figures, fine tuning consists of the following four steps. We train a neutral network model, example, the source model on a source dataset. Create a new neutral network model, example, for the target models. This replicate all model design and their parameter on the source model except the output layer. We assume that these models more parameter contain the knowledge learned from the source datasets, and this knowledge will be equally applicable to the target dataset. We also assume that the output layer of the source model is closely related to the labels of the source datasets and is therefore not used in the target model. Third, add an output layer whose output size is the number of the target dataset category to the target models and randomly initialize the model's parameter of this layer. Fourth, train the target models on the target dataset such as chair dataset. You will train the output layer from the scratch, while the parameter of all remaining layers are fine-tuned based on the parameter of the source model. Hot dot recognition. Next, you will use specific example for practice hot dot recognition. You will fine-tune the ResNet model trained on the ImageNet datasets based on a more small dataset. These small datasets contain thousands of images, some which contain a hot dot. We will use the models of them to fine-tuning to identify whether an image contains a hot dot. First, import the package and modules required for the experiment. Current model tools package provide a common pre-trained model. If you want to get more pre-trained models for computer vision, you can use current CV to get the dataset. The hot dot dataset we used was taken from online image and contained 1,400 positive images containing hot dot and the same number of negative images containing of the food. 1,000 images of various classes are used for training and the rest are used for testing. We first download compressed datasets to the path data. Then we unzip downloaded dataset in the path and get a two folder hot.train and hot.test. Both folders have hot and not hot category subfolder, each of which corresponding image file. We create a two image folder dataset to read all the image files in the training dataset and testing dataset respectively. The first 8 positive examples and the last 8 negative images are shown below. As you can see, the images vary in size as in aspect ratio. During a training, we first crop a random area with random size and random aspect ratio from the image and then scale the area to an input with a height and width of 224 pixels. During testing, we scale the height and width of the image 256 pixels and then crop the center area with height and width of 224 pixels to use as input. In addition, we normalize the value of the 3 RGB red, green, blue color then channel. The average of all values of the channel is subtracted from each value and then the result is divided by the standard deviation of all values of the channels to produce the output. We use ResNet 18, which was pre-trained on the ImageNet dataset as the source model with specific pre-train equal to true. To automatically download and load the pre-trained model parameter, the first time they are used, the model parameters need to be downloaded from the internet. We first define a training function, train fine-tuning, that used for tuning so it can be called multiple times. We set the learning rate in the trainer instance to a smaller value such as 0.01 in order to fine-tune the model's parameter obtained in pre-training. Based on the previous setting, we will train the output layers parameter of the target models from scratch using a learning rate 10 times greater. For comparison, we define identical models. By initialize all of its model parameters to random values, since the entire models need to be trained from scratch, we can use the largest learning rate. As you can see, the fine-tuning models tend to achieve a higher precision in the same method because the initialized value of the parameter are better. Thank you.